Hey folks, welcome to this episode on calculating empirical formulas. In this particular episode, we are going to be looking at some pretty straightforward empirical formula calculations. We are going to enhance this with situations where you might receive a decimal. That's going to be in a different video. And then we're going to bring it all together to see how we can use these to calculate molecular formula, again, in another video. So let's watch this first and learn about this first so that we can get a fundamental understanding of how to create empirical formulas and then do a couple extra steps to turn that into a molecular formula. Now, let's start off with the steps on creating empirical formulas. What you'll be given is you'll be given a percent composition, so by mass. That's something that we looked at in a previous video, and you can take a look at my other video playlist to find that video if you're still unsure about how to calculate percent composition. Using that percent composition, we are going to employ our first law, which is the law of conservation of mass. And what we're going to do is we are going to assume that we have 100 grams of the sample in the question. Now, why 100 grams? If we have, for example, given carbon, and that's given to us as 35.01%, and we have 100 grams of sample, that's going to be an easy conversion into 35.01 grams. Remember that if we had 10% of 100, that's going to be 10 grams. So 35.01% of 100 grams is going to be 35.01 grams. So this is going to be our first application of our law, and in this case, it's the law of conservation of mass. Next thing is that we are going to convert the grams of each element into moles using the molar mass of that particular element. Now, in the case of carbon, we are going to be using its molar mass, which is found to be 12.01 grams per mole. And we are going to use that to convert this mass that we got into moles. And again, remember, that's our universal currency in chemistry. We want to pretty much get everything into moles and work from there. If you have elements that are typically something like diatomic molecules, H2O2, we are only using the molar mass of a single atom. So for example, if you run into hydrogen, which is a pretty common one, you're not going to be using 2.02, you're going to be using 1.01 grams per mole. So the mass of a single atom. Next, we're going to look at all the mole values that we got, and we're going to find the smallest mole value. Now, this is where our second law is going to come into play, and this is the law of definite proportions, where remember that these elements exist in ratios. And by finding the smallest mole value, we're going to take that value and divide all the other mole values by that value and create a ratio. And this is going to give us the conclusion or the result of the law of definite proportions. From those values or those ratios that we're going to get, those become our subscripts in our empirical formula. So let's get started. Let's do an example here. So in this question, it says calculate the empirical formula from a sample containing 43.4% sodium, 11.3% of carbon, and 45.3% of oxygen. Now, one thing to note, remember that percent composition, it should equal 100%. The first thing that we want to do is we want to write down that we are going to assume 100 grams of sample because we have to convert these percentages into grams. So I'm going to write that down, assume 100 grams. All right. I'm going to split up my elements and I'm going to try to work across the page. It just makes things a lot cleaner and easier to read. And if you are messing up somewhere and you're saying, I don't really know, it's easy just to read across the line and try to find the mistake. So first things first is let's write out our elements. We're going to have Na, we are going to have C, and we are going to have O. All right. So now, if we assume that we have 100 grams, these percentages are just going to turn into their equivalent grams. So if you have 50% of 100 grams, that's going to turn into 50 grams. So in this case, we have 43.4%. So of sodium, we have 43.4 grams of sodium, 11.3 grams of carbon, and 45.3 grams of oxygen. Awesome. Next step is that we want to find the molar mass of each element and use that to convert these grams into moles. So the molar mass of sodium from your periodic tables is going to be 22.99 grams per mole. Now, if you're wondering, hey, how did you know to divide that? Use your dimensional analysis. So I know that I want to get rid of grams. I'm going to put the grams on the bottom, and I want to be left with moles. So I'm going to put that on the top. The only unit that we know that has both grams and moles is the molar mass. Molar mass of what? Molar mass of the element that you're looking for, or compound in other questions. So the molar mass is going to be, for carbon, 12.01 grams per mole. So that number belongs with the grams. And so since I put my grams on the bottom, I know that I'm going to put that number with the grams, and I'm dividing in that particular case. Same thing with oxygen. I'm going to put my grams to cancel out the grams, be left with moles, and the molar mass of oxygen is 16.00. Again, we are only using one atom, not the diatomic molecule. Alrighty, so in each of these cases, our grams will be able to cancel out, and we will be left with moles in every single situation. So what do we get? Now, I'm not going to round. I'm just going to truncate the number instead of writing the whole number, but I don't want to round it. I'm going to leave the full numbers in my calculator and then do the next step so that I can get as close to the number that I need later on. So this first calculation is going to be 1.8877 mole of Na. The second one is going to yield 0.9408 mole of carbon. And here we're going to have 2.8312 mole of oxygen. Alrighty. Now we have 3 mole values, and we're going to try to find the smallest mole value. And that one's pretty easy to spot. It's this one right over here. Now that we've found the smallest mole value, what we're going to do is we're going to take every single mole value and divide it by the smallest one to get a ratio. Again, the law of definite proportions. So I'm going to take this and divide it by 0.9408 mole. I'm going to do the same thing for here. And sometimes it's just quicker to just say division and then put little quotation marks to show that that's the same number instead of writing it over and over and over again. All right, now in each of these cases, the mole values will cancel out and you'll be left with a unitless number or a ratio. And so let's take a look at what those ratios are going to be. For this one, it's going to be 2.00648. This one, it's the same number. It's going to be a straight one. And in this particular case, we're going to have 3.00935. Alrighty. Now we know that our subscripts don't have decimals. They are whole numbers without any kind of decimals. So what we can do is we can try to round these. Now, in cases where these are really, really close, so anything, for example, between like 2.00 and 2.1, we can round this down. Okay, so we can round this down, and that certainly falls into that category. So we're going to round this down into 2. Now the same thing here, this falls between 3.0 and 3.1. So again, we can round this down as well. Now, we're making that clear right from the get-go because the next episode is going to deal with situations where you might not have a number that you can easily round. It's something that we're going to have to address in that next episode. So in this particular case, we can round this to 3. Congratulations, you have just figured out your subscripts of your chemical formula. And so if we put this all together, we have, so empirical formula is going to be sodium. And sodium, when we look at sodium, it has a subscript of 2. Carbon has a subscript of 1. And oxygen has a subscript of 3. Now we can simplify this by removing that 1, and we will get Na2CO3. And if you remember how to name this, this name is going to be sodium carbonate. That's it. Okay? So once again, assume that you have 100 grams. Convert all your percentages into your grams of that. Find the molar mass of each element and convert this into moles. From these values that you get, find the smallest mole value and divide each number by that smallest mole value. And then you will get your subscripts. If they're close enough to round down or up, then please do so. If they're kind of in the middle, like a 0.25 or a 0.5 or a 0.33 or 0.67, then don't round those. We're going to show you how to deal with these a little bit later on in the next episode. So I hope you found that helpful. Thanks very much for watching, and see you on the next one.